Okay, so section 1.3 here. It's called models and applications. Okay, models and applications. And we've really only talked about linear equations so far. So all these models are linear equations. Okay. Okay, so here's our first subheading here. We're going to be problem solving with linear equations. So, so before we get to an example of this, I'm going to go ahead and write out our strategy for how we're going to do this. Okay. So the first step in this strategy is, of course, to read the problem carefully. It's a word problem. Okay. Read the problem carefully. Okay. And then after you read the problem carefully, maybe a few times, right? Then you'll try to state it in your own words. All right. State the problem in your own words, which is pretty important to your understanding of what the problem is actually asking for. Okay. So state it in your own words. Okay. So what is the problem asking for? Right? And so we're trying to take this like paragraph, right, and turn it into like a mathematical equation, right? So we need to introduce variables in there. So let's let x be one of the unknown quantities, right? And there might only be one unknown quantity in there. I don't know. Or it could be more than one, but let x be one of the unknown quantities. Okay. So that's step one, right? Okay, so now that you've done that, right, and now that you've let x be one of the unknown quantities, right, there might be other quantities as well, right? You could call those other variables, but ultimately, right, we're in college algebra, we're dealing with just functions of a single variable x, right? So we should be able to express all unknown quantities in terms of x. So my step two here is if necessary. Write any other quantities in terms of x. Okay, and we're going to see what I mean by that in an example. Okay. All right. And now that you've done that, so you've expressed all the different quantities that are stated in the problem in terms of x. Now, right, it's asking you to look for something, right? So you're going to write an equation in x, right? So it's going to be an equation with variable x in there, right? That models the problem. What does it mean to model the problem, really? Well, you've already stated what the problem was asking for in your own words. So this equation should represent what this problem is actually asking for. Okay. All right. Step four. All right. You have an equation, so now solve the equation for x. All right. Find out what x is equal to, and answer the problem. Right. All right. So that's step four. Okay. All right. So now that we have that, right? Now the very last step is you got this x value, right, from solving that equation. Okay. Now we're talking about real world problems here, right? So maybe X is the I don't know, the number of tablets sold at this particular store or something like that, right? That's the unknown quantity, let's say, right? So if you solve this equation and you got that X is a negative number, it doesn't make any sense, right? Fair enough. You're trying to, it's supposed to represent the number of something sold. You can't sell a negative amount of stuff, right? Yeah. So you have to compare it to the context of the problem, the original wording of the problem, to see if the answer that you got actually makes sense in the context of the problem, right? So the last step here is to check the solution, right? That x value that you found in the original wording of the problem. original wording of the problem. All right, so that's a 5-step process, right? And it works for pretty much every equation, every linear equation, basically. Okay, yeah. So if it can be modeled with a linear equation, well, there you go. Yeah. So any questions on that? Can everybody read all of that? Does anybody need me to repeat anything I just said? Okay. I've hid my coffee from myself. There we go. Okay. So now let's get down to an example then. In this example here, right? So let's say you're choosing and like I said, these are very wordy, right? They kind of have to be, yeah, so that it's not ambiguous what they're asking for. So you are choosing between two long distance telephone plans. This is a somewhat of an antiquated problem now. I mean, now we can just Skype with people across the world, right? Yeah, but back in the day, yeah, we used to have to do long distance phone calls, right? Yeah. Oh, I guess Skype is antiquated too. It shows how old I am. Long distance telephone plans. Okay, so we're going to call them Plan A and Plan B, right? So Plan A has a monthly fee of, let's say, $20. It's pretty nice. Okay, with a charge of, remember you're doing these long distance calls, right? So it's a charge of 5 cents, which I'm going to write this way, $0.05, right? Yeah, so 5 cents per minute for all long distance calls. Okay. So that's Plan A. And now you're comparing it to Plan B, right? Now Plan B has a monthly charge. I'm going to scroll up a little bit here. A monthly charge of $5 with a charge of 10 cents. So dollars, that's $0.10 per minute of long distance calls. Okay. So there's Plan A and there's Plan B, right? And so here's what we want to know. For how many minutes? Of long distance calls will the costs, the cost of Plan A and the cost of Plan B, be the same? Yeah. So how many minutes of long distance calls, right, will it take in order for Plan A, that cost to be equal to Plan B cost, right? Okay. So that's basically step one, is to try to, phrase it in your own words there, right? Yeah. Fair enough. So I'm just going to write down our step one over here, right? And phrase it in our own words. We want to know the number of minutes. So this is my abbreviation for number, right? The number of minutes of long distance calls I said the number, but I meant what number? Ooh, that was weird. Ooh, will that erase? It will. Okay. What number of minutes of long distance calls will make Plan A cost the same as plan B. Okay. So there, I've expressed it in my own words, right? Okay. So I got to let X be one of the unknown quantities here, right? But there's only really like one unknown quantity, right? It's the number of long distance minutes, right? Okay. So then I'm going to let X be the number of long distance minutes. Okay. Any questions on that? Any questions at all? Okay, so that's step one. All right. So on to step two then. Step two, right? That's the one where we need to write any other quantities in terms of x, right? So we have this unknown quantity x, right? The number of long distance minutes, right? But there's also plan A and plan B, right? How much do they cost, right? Fair enough. So it says that plan A, well, there's this $20 monthly fee, which you're going to be paying, even if there are no minutes of long distance calls, you're still paying that $20 fee, right? So plan A, which I'm just going to call A, is at least $20, right? Yeah, and then for every minute of long distance calls, we got to tack on another 5 cents, right? Another 5 cents. So then, in addition to this $20, right, we also have to pay 5 cents per minute of long distance calls. So if there are X minutes of long distance calls, then 5 cents times X would be the cost of those long distance minutes that are added on to the monthly fee, right? Okay, so I'm going to pause there for a second. Any questions on that at all? All right. Any questions on that at all? So that door slamming shut so much that that thing is vibrating up there, and it's just shaking the screen up and down. It's crazy. Oh, yeah, it's $20 plus 0.05 X, right? Because it's 5 cents per long distance minute, right? Yeah, so, okay. Okay. So any questions on that at all? And if you want, right, we know that we're talking about dollars, so you could just write, you know, leave the units off there. Yeah, that's fine. Okay. Okay. So now let's do the same thing for B, right? So B has this base cost of only $5, right? So that's $5, right? And then we have to pay 10 cents per minute, right? So that's going to look very similar. 0.10 times X, right? And so this is the same thing as having 5 plus 0.1x, right? You can write it that way if you wanted to. Yeah. All right. Any questions on that? All right, so that's plan A and that's plan B, right? Now we go on to step three. Step three is where we're looking the thing that we're actually looking for. We need to express it as an equation, right? Okay. And so what we're looking for is after how many minutes will plan A be equal to plan B, right? So we're literally setting A equal to B, right? Fair enough. Setting A equal to B there. Okay. So my A, that's 20 plus 0.0. Oops. Oh, wait, hold on. Let me just try this again. Can I erase that? Can I erase this one? No. All right. Got too greedy there. 20 plus 0.05x. That's what my A is, right? And I'm setting that equal to B, which is 5 plus 0.1x. Okay. Yeah, so that's my equation, right? That models the thing that we're actually looking for in the problem, right? So any questions on that at all? Okay. Well, good. Now that we have that, okay, so our step four is now we solve this equation, right? Yeah, we have this linear equation over here. So I have 20 plus 0.05x is equal to 5 plus 0.1x, right? All right. I think I'll start off by subtracting 20 on both sides of the equation. Okay. Yeah. So I'm going to take the left-hand side here. I'm going to subtract 20 from it. And that's going to be equal to the right-hand side, also minus 20, right? Okay. So my 20s cancel off, and I'm just left with 0.05x on the left-hand side. On the right-hand side, I have a 5 minus a 20, which is negative 15, plus 0.1x, right? Okay. Now I'm going to get all my x's on the left-hand side, right? Okay, so let's do that. So I need to subtract 0.1x on both sides of the equation there. So I'm going to take my left-hand side here, and I'm going to subtract 0.1x. I'll take my right-hand side here, and I'm going to subtract 0.1x. So my 0.1x cancels with this. So I'm just left with negative 15 on the right-hand side, right? Got to do a little bit of quick math here. I basically have 5 cents, and I'm taking away 10 cents from that. So I'm going to be left with negative 5 cents, right? So this would be a negative 0.05x, right? Okay. And of course, you could use a calculator on that if you're not really good with decimals, right? All right. Now, I have to get x by itself, right? So then I need to divide by negative 0.05, right? So you can see that pretty much all the work in the problem comes in step 4, right? Everything else is just like, do I understand what the problem's asking for, right? Yeah. But now, here's the actual math, right? So I'm going to take both sides of the equation and divide by negative 0.05, right? So here I have negative 15 over negative 0.05, right? Okay, so my negatives are going to cancel off, right? So I'm just going to have, and my 0.05s are going to cancel off as well, right? So I'm just going to be left with x on the left-hand side. On the right-hand side, my negatives cancel off. I have 15 over 0.05, which again, you could use a calculator for, okay? You can also do this one pretty easily in your head, right? You know that we can multiply a fraction by 1 without changing the value, right? So as long as we're multiplying by 1, it's just fine. So this is a neat little trick, which I probably showed you before, but maybe not with decimals. Okay, this is certainly something you're going to do in trigonometry. So I can multiply the top and the bottom by 100 if I wanted to, okay? Because 100 over 100 is equal to 1. So I'm really just multiplying by 1, but in a funny way, right? So up top, that's going to be 1,500. And then down below, right, well, 0.05 times 100, that just means we move the decimal place over 2 spaces, right? So we get 1,500 over 5, right? Okay. Now that I have that, well, 15 divided by 5 is 3, all right? So we're going to get 300, okay? So x is equal to 300, okay? And what are the units of x, by the way? Minutes, exactly, minutes, right? Not dollars, but minutes, right? X is the number of minutes of long distance calls, right? So if you want, we can say 300 minutes, okay? Great. All right, so good. So now we found x is equal to 300 minutes, right? Now we have to phrase it back in the context of the problem here, right? So after 300 minutes, plan A and plan B will cost the same, right? And so we stare at that, we make sure it makes sense in the context of the problem. Is it possible to do 300 minutes of long distance calls? Yeah, it is. Okay, so there we have it. Okay, so that's the end. Any questions on that? Yeah. Oh, so I saw that it was 0.05 downstairs. So if I wanted that to be a whole number, right? This is called the hundreds place. So if I multiply it by 100, then that'll move the decimal place over just enough in order to get the decimal place past the 5, right? Yeah. And if I multiply by 10, it moves it 1 space. If I multiply by 10 squared, it moves it 2 spaces. If I multiply by 10 cubed, it moves it 3 spaces, and so on and so forth, right? Yeah. But yeah, great question. Yeah. All right. Any other questions on that? So that was an example where we really only had the one unknown quantity, x, right? So let me do an example where we might have 2 different unknown quantities, okay? So let's see here. Example, you are, nope, we just did that one. That. All right. This one is about finding the dimensions of an American football field, right? So the length of an American football field right, is 200 feet more than the width. And I guess I should start off this way. We know that American football field is a rectangle, right? Yeah, so length and width are the dimensions, right? Okay. Yeah. In fact, maybe we'll go ahead and draw a picture of this. Here we go. Okay, right. So now that I have that, okay, so we now know that the length, right, which I'm going to say the length is this vertical distance here, is 200 feet more than the width. And I'm going to say this horizontal distance is the width, right? Okay, so width and length. Okay, fair enough. If the perimeter, Perimeter, is 1,040 feet, what are its dimensions? Yeah, fair enough. So there's our word problem there. Okay. So now that we have that, right, we'll go on to step one, which is, to read the problem enough times until we can understand what it's actually asking for, right? Yeah. And it's pretty clear dimensions, right? That's the length and the width, right? So what they're asking for is, well, what is the length of the football field and what is the width of the football field, right? Right. We are looking for the width and the length of the football field. Yeah. Okay. So there's two unknowns that we're looking for there, right? And one of them is the width and the other one is the length, right? So we can let x be one of those unknowns, right? And then we'll have to let, like, I don't know, y be the other unknown, right? Yeah, so since I drew the picture this way, I guess I'll call this x and I'll call this y, right? X is horizontal distance, y is vertical distance. Yeah, just kind of makes sense, right? Okay. You could do it the other way. It's completely fine. Yeah. Now, let's let x equal to width and y equal to height. Okay. So that's step one. Okay. So any questions on that? Okay, now that we have that, we're told that the length is 200 feet more than the width, right? This length is 200 feet more than the width. So if I look at y, right? Oh, I said height, but I meant length. Sorry about that. Okay. So if we look at y, which is the length of the football field, right? Well, that should be 200 feet more than the width. So whatever the width is, which is x, right? If I add 200 feet to that, right, then that should be the length of the football field, which is y. Yeah, so y is equal to x plus 200. Yeah. So there we go. We've taken all of our other unknown quantities, we've expressed it in terms of x now, right? So everything's written as sort of this function of x, right? Yeah. Any questions on that? Yeah. Well, I guess we also have the perimeter to worry about though, right? Yeah, the perimeter. Well, so the perimeter is given to us to be 1,040, right? 1,040 feet. Okay. But if we look at the perimeter of a rectangle, in case you forgot what a perimeter is, right? It's the distance around the outside of the structure, right? So here we have x feet this way, and then we have y feet this way, and then we have another x feet this way, and we have another y feet this way, right? So I'm going to go ahead and label this. This is length y, this is width x. So if I add up all of these, then I get that the perimeter should be 2 times x plus 2 times y, right? And that'll be true for any rectangle. 2 times the width plus 2 times the height, because it's a rectangle, right? Okay. So any questions on that? Okay, so I've expressed the perimeter now in terms of x and y, but remember, y is the same thing as x plus 200, right? Yeah, y is the same thing as x plus 200. So then Oh, sorry, this is kind of step 3 right here. My mistake. Yeah. So the perimeter is 1040, which is 2x plus 2y, right? Okay. So that's just 2x plus, well, my y is x plus 200. So I'm going to replace y with what it's equal to. Okay. Fair enough. All right. And then now I'm going to simplify that a little bit, right? I have 2x plus, I can distribute this 2. I get 2x plus 400. So this is going to be a 4x plus 400 then. Okay. I'm going to clean it up just a little bit here. Right? So this is saying that 1040 is equal to 4x plus 400. Okay. So that's step 3, right? And so now we have an equation that sort of models what we're looking for here, right? Yeah. All right. Step 4 is to actually solve this thing now, right? So we have 1040 equals 4x plus 400. I'm going to start off by subtracting 400 on both sides of the equation, right? So I'm going to take my left-hand side here, subtract 400. And take my right-hand side here, subtract 400. Okay. All right, so my 400s are going to cancel off on my right-hand side there. Over here, 1040 minus 400 is just 640, right? And on the right-hand side, I just have 4x left over, right? So 640 is equal to 4 times x, right? Now I'm going to divide by 4 on both sides of the equation. So then 640 divided by 4 will be equal to 4x over 4, right? My 4's will cancel off right there. 4 goes into 64 16 times. So then 4 will go into 640 160 times, right? So x is equal to 160. Okay. So that's the width. Okay. Any questions on that so far? Okay, so we found the width of the football field. We still need the length though, right? Yeah. But that's okay. We have that y, right? The length is just x plus 200. So we're just going to use that relationship then, right? So this implies that y will be equal to 160 plus 200, which will be 360, right? So now we have the width and we have the length, right? Fair enough. Any questions on that? All right. Now, step 5 is to phrase it in terms of the context of the problem, right? So the width of the football field is 160 feet, and the length is 360 feet. All right, there we have it. Any questions on that? Any questions on that at all? All right. Well, um, as you're doing problems like these, you don't have to number your steps, right? Yeah. I mean, it's sort of good practice when you're first starting because, it sort of reminds you what you're supposed to do. Okay, so step 1 says what now? Then I do that. Step 2 says this, and then I do that, right? Yeah, but ultimately, like, as long as you're doing all of this stuff, it doesn't matter what step you call it, right? Yeah. Um, so I wanted to show you those 2 examples because I think it pretty much summarizes everything in section 1.3, right? But again, there's a lot of really good examples in the textbook with nice pictures and everything, right, in full color. So what I would like you to do, call this a reading assignment here. Reading assignment. Read through section 1.3 in the textbook, okay? It's shouldn't take you very long. There's probably like, there's at least 10 examples in there. Yeah. And so make sure you read through it before you attempt the homework on that. Okay. Yeah. Okay. So that's going to be it for section 1.3. Okay, and then I'm going to move on to section 1.4. Are there any questions?